Oh, I don't know how to do that. All right, so kinematics part 3. This will be our last kinematics session before we move forward into, I don't know, new territory. Okay, so let's try to do this thing. So your homework is going to be 1 and 2. All right, so we're going to work 3 and 4 together. All right, so let's start. So let me repeat for those that just joined in. Your homework is going to be problems 1 and 2, and I'm working on problems 3 and 4 today. All right, so this time around, let's start in order. Okay, so we're going to start with number 3. So number 3 says that the velocity in meters per second of a particle moving in a straight line is given by that equation. So we have that the velocity, depending on time, is given for e to the 3t minus 2, where the time is in seconds, right? So find the acceleration of the particle when the time is equal to 1. So let's do A. So acceleration is just the derivative of the velocity, all right? So the acceleration is the derivative of the velocity. So let's try to remember how to get the derivative of e to the u. What would be the derivative with respect to x of e to the u if u is a function of x? What's the derivative of that?
U, e to the u.
E to the u,
Times, yeah, well, I guess the derivative of u, right?
That is correct, Ram. Times u prime, okay? So in our case, u is 3t minus 2, okay, for this function. So b prime is going to be e to the 3t minus 2. And what's the derivative of 3t minus 2?
3.
3. So this is just 3 e to the 3t minus 2. So this is the acceleration. And part A is asking for the acceleration when the time is 1. So we just plug in 1 into that, okay? And that's going to be 3 times e, because 1 times 3 is 3, minus 2 is still e. And that's about 8.15. That's acceleration meters per second square, okay? Any question so far there? We're good? All right. So that's nothing new. We have done that. Take the derivative of the velocity to get acceleration. So let's try B. At what value of t does the particle have a velocity 22.3 meters per second? All right. So they're telling me that the velocity is 22.3 meters. The velocity at some value of t is 22.3. And they want me to find t. So what I have to do is set that number equal to the equation of the velocity. Okay, which is that. Then all I need to do is to solve for t from that equation. How do we solve for t in there when we have an exponential function?
ln, take the ln, and then add 2 and divide by 3.
Awesome. That is correct, Bram. So we're going to do ln of 22.3, okay, equals 3t minus 2, taking ln on both sides. And then we do what Bram said, which is add 2. So it's going to be 2 plus ln of 22.3 divided by 3. That's the value of t. And if we find that on the calculator, that's about like 1.70, right? Or 1.7 seconds. All right. Is Dory in the house? Dory's in the house. I don't see her. Doris, are you there? Don't see you. I don't think she is. Okay. All right, so that's B, right? So let's look at part C. Part C is find the distance traveled in the first second. So, all right, the particle is moving on a straight line, okay? So let's make a sketch of the graph so we get an idea what we need to do. So let's suppose this is S, right, the position. So when the time is 0, the particle is going to be somewhere, right? And when the time is 1 second, the particle is going to be at some other place. How do we find that distance?
You have to find S of t. You have to find the formula for displacement. So you have to.
Right. We're going to need the formula for displacement.
You need to integrate the velocity.
True. But once we have that, what do we need to do?
Oh, find the difference.
Find the difference, right? So what we're looking for is this, right? In order to find this distance, right? The distance, which is what they're asking us to find, we need to find the difference between the initial position and the final position, right? The position at 0 and the position at 1. That's our goal. But as Bram said, yes, it is correct. I need to find S first so I can find these two values. Makes sense? All right, so that's what we're going to do. So we know that the position will be the antiderivative of the velocity. Remember that this symbol stands for what? Antiderivative, which is the integral, correct? So we need to find the integral of b of t. Right? Which means we need to find the integral of the velocity, which in this case is e to the 3t minus 2 dt. So the question we're going to ask ourselves is, what function, right? Finding the antiderivative means what do we have before taking the derivative? So what function do I need to differentiate, to take the derivative of that will give me this? Think for a second and see if you're able to come up with an idea. What do I need to differentiate to get this? If you look at the acceleration, you might get an idea.
It doesn't matter. It wasn't you. So if you want.
Somebody's watching a novella or something. So please mute your computer or your video or whatever, okay?
You don't have.
Penelope?
I think I do.
It's not me. I was
Somebody-
gonna ask who's watching TV.
I just have to check one thing.
Lucia, are you watching TV?
No, I'm not. I'm trying to figure it out. I promise.
Okay, somebody's watching TV. Mac, are you watching some soap opera?
No.
Just messing with you, man, but somebody is for
Soap
sure.
opera?
No, bad, bro.
Ellie,
I'm
where
watching
are
La
you?
Rosa de Guadalupe.
All right, let's try to figure this out. All right, so look,
Is it like 1/3 e 3t to negative minus 2?
that is Mr. Tony. How do you figure that one out?
I can see.
Because like from the velocity to acceleration, it's like from e to just there's another 3 and times like I just want to make the number before e to 1, so I chose to like use 1/3 to times 3 to give the 1 and for the velocity
All right.
derivative.
That is correct. So let me rephrase what Tony said, right? Notice this. When you take the derivative of the velocity, we got 3 times what we had before, correct? 3 times the velocity. So what are we trying to find? We're trying to find something that when you take the derivative, you will give you this, right? So instead of having 3 times, because if I differentiate the velocity, I get 3 times what I had before. Then in order to get rid of this, I should need what? 1/3. Okay? So basically, this is what we just did. S of t is going to be 1/3 e to the 3t minus 2 plus some constant, right? If you differentiate this, forget about the 1/3 for a second. If you differentiate e to the 3t minus 2, we get the acceleration, don't we? Right? Which is 3 times that. Well, you multiply by 1/3, somebody's still watching something. I think it was Aria watching some soap opera, man. Come on. All right, so
No, I'm not watching Rosa de Guadalupe, bro. I never watched that show. Oh my god.
It's whoever's mic isn't muted right now.
Okay. So when you multiply by 1/3, this 1/3 and that 3 goes away, and what you get is the velocity. Okay? That's why this is the antiderivative of this is the position, right? Now that's just the position. We need this difference, s of 0 minus s of 1. So I need to find that. So let's see, s of 0 minus s of 1, because that's going to give me the distance, is going to be equal to. So if you plug in 0 into this function, you're going to get 1/3 e to the negative 2, right? Because t is 0, correct? Plus c. That's when I plug in 0. If I plug in 1, so what are we going to get? Minus 1/3, right? E to the first power, because t is 1, 1 times 3 is 3 minus 2, 1, plus c. So what happens? And since this is distant, I should have done actually, I made a mistake, kids. This should be s of 1 minus s of 0, because it's the final minus the initial. So I'm just going to put absolute value here because it will be the same thing, okay? So look, this c value and that value cancel. So the c value in this problem is irrelevant, okay? And then what do we have at the end? The absolute value of 1/3 e to the negative 2 minus 1/3 of e. If we do that correctly, that should be about 0.861. Okay. Now, I'm going to rephrase what happened. I should have done here s of 1, the final position minus the initial, but I didn't, and I didn't want to erase all this. So what I did is just take the absolute value because it's distance. It has to be positive. Make sense? All right. Any particular question? We're good? Good enough? All right. So that's number 3. Let's try then now number 4. All right. So number 4.
Mr. Sanchez, could you keep the number 3 up for like a minute? I'm just trying to finish up the working.
All right.
The bottom section. Could you possibly show the? Thank you.
Mommy, you keep interrupting me. I'm gonna charge you, man.
Ow. Thank you.
Lucky.
Are you good? I'm just teasing.
Yeah, I'm good.
You see, Arya muted his mic, and there is no more soap opera noise. I'm just saying.
Oh my god. Really? Okay. You got me. You got me. I'm watching the latest season of La Rosa de Guadalupe.
I don't know, man, but I know it's not The Sopranos for sure. All right, let's move forward. Number 4. Okay, are you ready?
Yep, I'm good.
All
Thank
right.
you.
All right, so let's do number 4. I wonder what happened with Doris. I hope she's okay. All right, number 4. It says the particle moves with a velocity meters per second given by that equation. So now we have the velocity is 25 minus 4t squared. 4t greater than 0. It says A, the displacement s meters is 10 when the time is 3. Find an expression for s in terms of t. So they're giving us the following information. It says that when the time is 3, s of 3 is 10, right? That's the first sentence there. The displacement s meters is 10 when the time is 3. Find s of t. Well, as we did in the previous example, s of t will be the antiderivative of the velocity, right? Which will be the integral of 25 minus 4t squared dt. All right. So let's find that antiderivative. What is the antiderivative of 25? What do we have to differentiate to get 25?
25t.
25.
Yeah, 25t.
25t. All right. Minus. Now let's think about this for a second, right? The derivative has an exponent that is 2. So before taking the derivative, what should be the exponent?
3.
3. So this is going to be t cubed. Now, if I were to differentiate this, then I will bring this 3 down, right?
Yeah, 4 over 3.
So I
4 over
need
3, 4 over 3.
I need 4 thirds. So when they will cancel each other, and I get the negative 4 plus the c. All right. Now this c, we're going to find it specifically because we're given this information. S of 3 equals 10. So that means that I'm going to set this equal to 10. I'm going to plug in 3. And I'm going to find C. So this is going to be then what? 10 minus 75, right? 25 times 3. This is 27 divided
36.
by 9, negative 36 plus 36.
Yeah.
Equal to C. So C is negative what? 29.
Yeah.
Right? All right. So the position then is, I'm going to put this in order, negative 4 thirds t cubed plus 25t minus 29. So this is the position function. All right. That's the position. Questions? No? Yes? All right. So if there are no questions, let's move to B. So let's do B. Find t when s reaches the maximum value. So that means that we need to find the maximum of this, right? Well, we have the first derivative with the velocity, which means that to find that, I need to take the derivative of the position, which is the velocity, and set that to 0 to find the critical numbers, okay? So I'm going to take the velocity, 25 minus 4t squared, and set that to 0, solve for t. 25 fourths is equal to t squared. Remember, the time is positive, So we're only gonna consider positive values here. That means that t is equal to 5/2, right? From there, this is my critical number. I need to check if that is a max or a min. So what we have done in the past is use the second derivative test. I'm gonna use that because this derivative, the first derivative, is quite simple. So using the second derivative test is not that complicated. So the second derivative is just the derivative of this, which is negative 8t. When I plug in the critical number into my second derivative, that is less than 0 anyway. So what does the second derivative tells me if it is less than 0?
Concave down, so as a max.
Concave down, right? As the function is concave down there, so therefore S has a max at t equals 5/2, right? Find the value of t, that's it. They don't want us to find the actual maximum, just the value of t, all right? So that's all then there. Let's look at C. The particle has a positive displacement for t between m and n. Find the value of m and n. So t is between m and n, and this tells me that the displacement is positive. Okay, Penelope, what happened? Did you bite your finger?
What? No.
All right, so the displacement is positive. What's the displacement function? This one, right? So that means that I need to take S of t and make it greater than 0. That would mean the displacement is positive, right? So I'm gonna take the function negative 4/3 t cubed plus 25t minus 29 and set that greater than 0. Okay, and I need to solve that inequality. But that inequality is not an easy one to solve algebraically, so we're gonna use the calculator for that. Okay, so we're gonna type this into our calculator and we're gonna set the window so x is greater than 0 because the time is positive only for this problem, right? So we're gonna enter this thing into the calculator, negative 4/3 t cubed, or in this case x cubed, plus 25x minus 29, okay? And since I don't know how this looks like, I'm gonna do zoom fit, zoom 0, and see what the calculator does. And I don't know what the heck is that, but that's not a nice picture because it's telling me that everything is negative. So I'm only gonna use this to get an idea how to graph it, okay? So I'm gonna look at the window. X between 17 and 53. Well, that doesn't help because we said that there is a maximum at 5/2. That is like 2.5, okay? So between 17 and 53, that's not really a good window for us. The time is positive, so I'm gonna do between 0 and 10. And look at these values, they're really, really small, I mean, negatives, right? And if it's crossing the x-axis somewhere, it has to be between one negative and one positive value. So I don't know, I'm gonna say, let's say between negative maybe 100 and 100. And I'm gonna do this by tens and see what it gives me, all right? So I'm gonna graph this thing and look, that's much better, right? So now I can see that the graph has a portion where it's what? Positive. So that's what I'm interested in. And it should be between this value and that value. All right. So I just need to find the intercept. So I'm going to do second calculate intersect 5. And I know the first one is between 0. Oops, shoot. Second calculate intersect. And I'm going to say between 0. What am I doing wrong? Intersect. Oh, it's not intersect. I'm sorry, it's 0, what I'm looking for. Second, calculate 0. Number 2. One of the zeros is between 0 and 20. Remember that my scale was by tens. So it's between 0 and 20. What the heck? No, I said between 0 and 10. So this is by 1. So between 1 and 2. I'm so sorry. So between 0 and I'm just going to move to the right. I thought I knew better. There. Press enter. What am I doing wrong? Somebody help me. Second, calculate. I'm looking for a 0. So the 0 is between this thing and this thing. Okay, why it was not working for me earlier, I don't know. But that value is like 1.268. So M, because M is the smallest value, M is about 1.268. And then N is the other one. So I'm going to repeat this. Second, calculate 0, then is between there, press enter, and there. So N is about 3.553. And that would be what I need. Okay. So you cannot just trust in the graph that the calculator throws you the first time. You have to make a little bit of analysis if what you're looking at makes sense or not. Okay. All right. So that's basically what I have for you guys. Let me talk about the quiz that I told you we're implementing. First of all, the quiz is going to be next week. So obviously, it's not this week. We're done for the week. Well, I don't see you Friday, so we're done for the week. All right. So the quiz is going to be next week. Next week, I'll see you when? Tuesday or Wednesday? When did I see you the first time?